The first application of integration, what we are going to learn is about the displacement, velocity, and acceleration. So before I start how it can be applied, I'm going to talk a little bit about the concept of the displacement, velocity, and the acceleration. So suppose if one person is going from one place to another, like maybe from point A to point B, the 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 distance which he covered, or maybe the displacement which we say if it is on a particular direction. So the displacement is nothing but the distance which we covered from the place A to B. Okay, and how fast the person is moving is given by the term velocity, and how the velocity is changing, or how the speed is changing, is given by the word acceleration. Okay, so these are the three words which we have to know. So the displacement is nothing but the distance, velocity is synonymous to speed, and acceleration, as we know, it's an acceleration, how fast it is changing. Okay, so usually when you consider the displacement, velocity, and the acceleration, we always map it to the time. So time is the factor with which we measure all the displacement, velocity, and the acceleration. Okay, so now for example, displacement, okay, before going, displacement is always denoted by the letter S, velocity is denoted by the letter V, and acceleration is denoted by the letter A. Now the displacement can be denoted as a function of time. So everything is dependent on time. Okay, so the displacement can be denoted as a function of time, which can be written as 3t square plus 2t plus 5. Okay, so in this case, t is the time taken. Okay, so displacement is the time. Now if given the displacement, to find the velocity, what you need to do is you need to differentiate this with respect to time. So v is equal to ds by dt. Okay, so you differentiate the velocity with respect to time, and then to find the acceleration, you differentiate the velocity with respect to time. So that's the relation which these three things hold together. So from displacement, you differentiate to get velocity, and from velocity, you differentiate acceleration. So to make it simple, what I'm going to do is I'm just going to write it like this. So we have displacement, which is denoted by the letter S. Then I have velocity, is denoted by the letter V, and then I have acceleration, which is denoted by the letter A. Okay, so displacement, if you differentiate, you will get velocity, and velocity, if you differentiate, you get acceleration. Okay, now coming back, if you have an acceleration, if you integrate acceleration, you will get velocity, and velocity, if you integrate, you get displacement. Okay, so and all this has to be done with respect to time. So time is the factor here. So that is why we put A is equal to dv by dt. Okay, so now for making this a bit more clear, so S is equal to, or maybe I will just start from this side, V is equal to ds by dt, A is equal to dv by dt. This is the differentiation cycle. And for integration, V is equal to integral of dA by dt. Integral of acceleration A dt, and S is equal to integral of V dt. This is the integration circle. So remember this cycle, this picture, and then you will be able to do all the problems of the differentiation and integration. Okay, let me just take a question here, and then we will try working alongside of that question. Let's look at this question. The acceleration of the body is given by A equal to 60 minus 12. Find the velocity v in terms of t, given that v equal to 9, then t equal to 0. So let's first consider only the first part of this. So I'm just neglecting this part. So considering the first part, finding the velocity v in terms of t. So what they have done is they have given the acceleration, which is 6t minus 12. So v, to find v with from the acceleration, what you can do, you need to differentiate a dt. So a in the sense acceleration. So in this case it will be 6t minus 12 dt, which is equal to 6t square by 2 minus 12t plus c, which is equal to 3t square minus 12t plus c. Okay, so we have found the velocity now. V is equal to 3t square minus 12t plus c. But c is a constant which we introduce when doing the integration. Okay, so you cannot leave this question like this. That is why the part 2 will help you find the value. So in the part 2, what they are saying is v is equal to 9 when t is equal to 0. So what you can do is, like, you can just sub in these values into this and you will get the value of the constant c. So subbing in the values, 9 is equal to 3 into 0 square minus 12. This is 12t. Okay, so 12 into 0 plus c. So all that will become 0. So 9 is equal to c. C is equal to 9. So in this case, v will be equal to 3t square minus 12t plus 9. So we got the velocity like this. Okay, now we need to find the second part of the question, that is to find the displacement s in terms of t, given that s is equal to 6 and t is equal to 0. So as in the previous case, always remember that this part is to find c. Okay, so from the previous section, what we have v is equal to 3t square minus 12t plus 9. Now our question, from the question, we have to find the displacement s. S is equal to integral of v dt, which is equal to integral of 3t square minus 12t plus 9 dt, which is equal to 3t cube by 3 minus 12t square by 2 plus 9t plus c. We can simplify this, which is t cube minus 6t square plus 9t plus c. Now again we have to use this s is equal to 6 when t is equal to 0. So 6 is equal to 0 plus 0 plus 0 plus c. So 6c equal to 6. So in that case, s is equal to t cube minus 6t square plus 9t plus c. Okay, so this is the displacement in terms of t. Okay, now moving on to the third part of this question, find the values of t when the body is at rest. Okay, so find the value of t when the body is at rest. So for the time being, let me just copy this and paste it here so that it is easy for me to work on. So now we have found the velocity and the displacement when the body is at rest. So the body is at rest means v is equal to 0. So what I can do, I can take this equation. So 0 is equal to 3t square minus 12t plus 9. Okay, again I can, since we have 3 in common, so I can write t square minus 4t plus 3 is equal to 0, or I can factorize this as t minus 1 and t minus 1 and t minus 3 equal to 0. So t is equal to 1 or t is equal to 3. So this is the values which we get for t. Okay, so that is how we solve. So the quadratic, we solve the quadratic. Sorry. So the main idea is you have to find out what the question is saying. So when the body is at rest, v is equal to 0. So that is a key point, and from there you will be able to find out all the values. Thank you.